Hi guys, welcome to section B. We're going to finish up chapter 14 today, and we're going to talk about waves, okay, ocean waves in particular. We'll talk a lot about waves in 8th grade science, and a lot of these same terms are going to come up, but right now we're just talking about them in regards to the ocean, okay? So a wave in general is a repeated motion that transfers energy, okay? You can have a wave going through like a jump rope or something. You can have sound waves. Ocean waves are a kind of a repeated pattern of energy traveling through that water, okay? Now, oscillations, when something oscillates, it's a repeated circular pattern, okay? So if you can kind of picture yourself at the beach, maybe you go out on a boogie board and you go out far enough that you can touch, okay, but barely, kind of deep. And as the wave comes, it kind of lifts you up because you float and your feet aren't on the ground anymore. What's happening is the wave comes in and it kind of pushes you back a little bit, and then it drops you down, and then it brings you forward, and then it lifts you up and it takes you back. And so you're actually, kind of following this circular pattern. And so that's how these waves move, is with these oscillations, okay? The wave height is the distance between a crest and trough, okay? So the crest of a wave is its highest point, the trough is its lowest point, and so the wave height is the difference between the two, okay? And this is kind of out at sea we're talking about. We're not talking about waves at the coast yet. The wave length then is the distance between either two crests or two troughs. Okay, so here's a crest, so the wave length would be that right there, okay? Now the wave base is the deepest part of the water that's affected by the wave. The wave isn't just happening on top, it's moving water underneath it. And so if you look at page 346 in your book, you're going to see like these repeated circles underneath it. The wave base actually travels down underneath. It's not just at the surface, okay? And then finally, the wave period is the time between crests. So it has to do with how fast or slow the wave is moving, okay? That's the wave speed, how fast it's moving, okay? So those two things are really, really related, really similar, okay? So let's talk about how waves are generated, how they're made. Hands down, wind produces most of the waves, okay? Now, there's this thing called fetch, and it's the distance that the wind is actually blowing along the surface of the water. The longer the fetch, the more energy there is, and so you're going to have a bigger wave. So, in general, the windier it is, the choppier the water is. I mean, that kind of makes sense, right? Because the fetch is going to be longer. But the length of time that the wind is blowing and the speed of the wind also has an effect on the waves, okay? If like a single gust comes through, it's not going to, it'll cause a couple of little ripples, but it's not going to have a chance to really build on itself. If it's windy for a while, those waves are really going to be able to get big, and they don't go away once the wind stops. They kind of keep traveling for a while, okay? Now we get some other types of waves besides these regular ones. We get something known as high splash waves, and those occur when something big falls into the ocean, and that might be like a meteor or a chunk of iceberg or something like that, okay? And then what happens is it splashes, I mean, duh, but then it ripples out from there, just like dropping a pebble into a pond. These large objects cause the waves to go out from there. There's also something known as internal waves, okay? So the water up at the surface might be warmer than the water below it, okay? Or there's a difference with the salinity or sediment or something. And so if you have layers that have different densities, the movement is going to be affected, and you might actually get these little waves underneath. Just like we talked about the underwater waterfalls and the underwater lakes because of different densities, you can actually get waves under the surface, and they're called internal waves, okay? And then there's tsunamis. These are not tidal waves. We kind of commonly refer to them as tidal waves, but that's actually incorrect. A tsunami is a very large wave, and it's not a single wave, it's multiple, but the first one is always the biggest, caused by an earthquake out in the ocean. Tidal waves are just the difference between high and low tide. It's just those tides or those waves along the coast, okay? All right, so speaking of tides or waves along the coast, waves at the coast act much differently than waves out in the deep sea, okay? So these are known as shallow water waves. So as the wave nears the shore, the wave base hits bottom, okay? So when we're out in deeper water, all of that movement has room and it can move along. But as the slope starts to go up, as the continental shelf starts to appear, the base actually starts bumping into the bottom, okay, and bumping into the ground. And this causes the crests to get closer together, so our wavelengths get shorter, causes the waves to slow down a little bit, and it smushes those round oscillations together, and they get kind of smushed together, and they become more oval, okay? That water has to go somewhere though, and that energy and that movement has to go somewhere. And so what it does is it starts pushing the wave height up higher, but it also starts to get pointy, and that's unstable. And so eventually that pointiness falls forward, and it always falls in the direction that it's moving, okay? That's known as a breaker. That's when a wave falls over, it breaks, okay? And then at the coast, sometimes we get this thing known as a longshore current. Waves don't always hit the beach in a nice parallel pattern. Sometimes because of the shape of the coast, sometimes because of wind, sometimes because of sandbar, all kinds of things. The waves might actually break at an angle and they might move along, and that causes extra erosion, which we'll talk about in just a second, okay? So it's important to understand that the wave might actually break a couple of times. It might break a little farther out, and then there's still some energy, and then it breaks closer to shore again. We're obviously familiar with the ones that are breaking right at shore. Out where it's deep enough, though, it's just these kind of smooth patterns, and the waves don't break. You might get little ripples at the top if it's really windy, but the waves are totally different out there, okay? All right, so let's talk about a rip current. Let me move myself out of the way here. There we go. So a rip current, so as a wave comes in, you can see these waves. You can see these multiple waves here, okay? They bring the water and stuff in, but then gravity pulls them back out. So you know this, you've been at the beach, okay? But sometimes we get this thing known as a rip current, and it's a really fast current that pulls the water back out farther than usual. And it's got enough energy behind it that it actually, like, I'm not sure what comes first, chicken or the egg here. I don't know if the rip current causes the waves not to break, or if the rip current goes there because the waves aren't breaking. But in any case, you can see this kind of blank pattern in the water there. There's no breaking waves right there. It's a gap between those breakers. If you get caught in it, it could be pretty dangerous because, you know, these waves will take you a certain different distance, but then another wave's coming right back in. And so these outgoing waves, or that outgoing water, isn't going to drag you out to sea very much. But this rip current, because there's nothing coming in this direction, it can actually drag you out to much deeper water. And people get caught in these and need to get rescued all the time. But the good news is they're usually pretty narrow, okay? So if you ever get caught in one, you're supposed to swim parallel to the shore, either direction, and try to get out of it. You'll be moving in this direction, but as you're swimming that way, you're going to kind of go in a diagonal pattern. And once you're out of it, then you'll be able to go back to shore, okay? And just look for them. Look for an odd gap in the breakers and steer clear of it, okay? All right, so at the beaches, we get a lot of erosion because of all this water, and there's a lot of sediment in the water, and we get some deposition. A beach is basically a collection of deposited sediment, okay? So there's been erosion, the sediment comes in, and it gets deposited. That's a beach, okay? The waves then continue to shape that beach. The coarser the sand, the steeper the beach, okay? You can see kind of a cliff-sided beach right there, and that probably have really, really coarse sand. The flatter a beach and the less erosion like that there's been, it means it's really fine. It's kind of like sandpaper. Coarse sandpaper causes a lot of erosion. Fine sandpaper, not as much. So sometimes beaches will build these things called groins. And what they are is it's you know, I'll try to draw it here. It's like this little outcropping that comes out from the beach, and they build up this land right here. And you can actually see a picture of one, much better than my drawing here, on page 350 in the book. And what it does is it prevents the longshore currents from carrying sediment away. So if the waves are kind of moving at an angle, they're going to kind of take a lot of sediment down from the coast. But if this groin, if this longshore current hits the groin, it's going to be forced to deposit its sediment there. And so it keeps the sediment at the beach. It prevents some of that erosion from happening. Okay? Whew, that's it for chapter 14. Bye.